All right, happy Monday. Welcome back. Grace is sick, so I am home with her. But you will need to have out your page 353 homework, number 1 through 12, and I want you to do these as a bell ringer. So now that you're logged on, you're most likely listening to this through Canvas. And if you are with your own headset, then you're welcome to pause them at any moment. So go ahead and pause right now. Make sure you have your homework out. Make sure you also have the expressions and equations sheet for your lesson today. And pause and do these expressions, right? Expression, now remember, an expression has to have a variable, an operation, and one number or more, all right? Okay, so let's look at the first one. Anna baked 3 batches of cookies with C cookies in each batch. So she made 3 batches, C cookies, that's our variable. And then she ate 8 cookies. If you're eating cookies, you're taking them away. So I know that this is going to be a minus before my 8 cookies. So I'm gonna have something and then go ahead and minus 8 cookies. So whatever makes most sense to you, this is not a -8. I mean, it's like a -8, it's a plus -8, I guess. If she made 3 batches of cookies, that's like 1, 2, 3, and each batch had C number of cookies in each one. What does that look like? It's 3 times C. So 3C, and then she ate 8 cookies. So whatever number of cookies she had in each one, I could tell you, oh, there were 12 cookies in each batch. So you could go 3 times 12 minus 8. So sometimes if you think of a number for the cookies, on Friday when some of you had questions on number 11, on how to write those expressions, I often said, okay, so how many miles, if you had 10 miles, how would you figure that out? You're like, oh, you would times 17 cents by 10 miles. Yes. So if you had 5 cookies for each batch, how would you figure that out? Oh, you do 3 times 5, 3 times 5 or 8 or 10 or whatever C is, whatever this variable is. So sometimes it's easier to write it like this and then like plug in the variable where it goes. Okay, let's try this one. Ben has B dollars, so here's your variable, and Cam has 7 fewer dollars than Ben. Guess what? That's 7 fewer. That is not 7 minus B. That means B fewer than 7. No, many people will make that error. So if you wrote 7 first and then did B fewer, nope. 7 fewer than something, you have to have something to start. And then you can take 7 fewer than that. 7 fewer is minus 7. So whatever, if Ben has $10, Cam has 7 less than that. So he has $3. The last one, Gretchen is setting up for a banquet. She has 300 chairs and needs to distribute them evenly. What does distribute them evenly sound like? Pass them out. Group, group, group. 1 for you, 1 for you, 1 for you, 1 for you. That's divide. Divide among T tables. So you don't know how many tables there are, but you're going to take those chairs and you're going to pass them out 1, 2, 3, 4, 5, 6 to T tables. So if there are 3 tables, each table would have 100, right? So 300 over T. Not this. If you wrote this, I get you. I understand that that's what that means, but this is algebraically how we're going to write that expression. All right. Okay. Let's turn to page. You guys are on 353, 1 through 12. Let me give you some answers, and then I'll go over those difficult ones down at the bottom. So top ones. Number 1 is 34. Number 2 is 2. Number 3 is 3. Number 4 is 24. Number 5 is 3. Number 6 is 71. Number 7 is 2. Number 10 is 100. Number 9 is -1 because a negative divided by a positive is a negative. This one right here, if you put it in your calculator just like this, you're really telling it to do this. And what's it going to do first? Well, PEMDAS tells them to do that first, which would be 8 minus 2, which is 6. So if you got 6 here, you put it in the calculator. You didn't tell the calculator to do the right thing. What you need to do is add some parentheses, or else go ahead and do the numerator first, because remember, we've got to do the numerator first before we do anything with the denominator. Like if there's stuff in the numerator, like up here, you have to do this one first. Otherwise, it's going to divide 25 divided by 5 and not do, anyway. All right, so you're welcome to pause and take a look at any of those or try them again in your calculator. Down on number 10, you really had to read through. They give you the expression to be used to find the total cost when you're going bowling, and they tell you that N is the number of games. they tell you that 2 is how much shoes are. So this is like the shoe rental. It's going to be $2 no matter what, right? And then it's going to be $5 for every game. And then it tells you 3 games. So you plug in 3 for n. 5 times 3 plus 2. That's 15 plus 2. So it's going to be $70 for your total. Now, number 11 and 12 were tough because you actually had to write some expressions. So this first one right here, you have to write an expression and then find the cost. So you need to do 2 things. So if you don't have 2 things done on your paper and you just went straight to finding the cost, you're missing out on writing that expression, which is really important. Now, it's okay if you found the cost first and then kind of backtrack and change what you wrote down to find it into an expression. That's one of the strategies. So on option 2 here, you got to think, okay, what do I have first? This is going to cost me, no matter what, no matter how many miles I've got, it's going to be $50. So I've got $50, and I also have to pay per mile in this case. This one's a little different. So how much do I have to pay per mile? I have to pay 17 cents per. That means for every. That means times. Now, if you don't know right away, if that per mile doesn't tell you right away, like that's times, because sometimes we think of per mile as like divide, but for every mile, you're multiplying it for every mile that you go. If you don't automatically think times like, oh, we're just going to squish these things together, you can think, well, if I had 10 miles, how much money would that be? Well, it'd be 17 cents times 10. And a lot of you can tell me that because we've done stuff like that since 3rd grade. Now, if you're multiplying 17 cents times 10, then you're multiplying 17 cents times miles. So you can just pop the m in the place. So 0.17 m. This is your expression. It has to have a variable, it has to have an operation or 2, and it has to have a number or 2. Now you can go ahead and plug in for 150 miles. How much would it be to rent this car for 150 bucks? Like, this is absolutely real life, for sure, what you're going to do to estimate the cost if you go on a trip and you rent a car. I've done this every time I've rented a car, thinking, okay, I'm going to pay this much. It's going to cost me gas because this doesn't count gas as well. And you can figure out gas algebraically. So this stuff happens all the time. So let's see, 50 plus 0.17. And here m is 150. And when you do that out, you can put it right into your calculator if you want. 50 plus 0.17 times 150. And that'll give you 75.5. Don't just write 75.5. We're talking about money here, folks. So add the 0 in the hundreds place because it's not 5/10, it's 50 cents. Okay. Now on option 2, it's a little bit different because you don't just pay flat rate. You're actually going to pay a certain amount per day. So if you were, you would have to decide between these options. Since the price per mile is the same, we're going to use the same chunk right here. You're still going to use 0.17 m plus, but this time you're going to do $19.99 per day, which is just like per mile. So you're multiplying still. So it's $19.99 per day times d. So however many days you would plug in. So we got 2 variables. This one depends on days and miles too. Then they tell you 2 days and 70 miles. So you plug in $19.99 times 2. That's $19.99 per day plus I'm going to go 70 miles in those 2 days, which isn't very far. And then you can pop that into your calculator. When we do that, 19.99, oops, delete, times 2 plus 0.17 times 70. And our answer is $51.88. I'm kind of curious as to how much it would cost for 150 miles since we figured it out for the top one. I'm going to just do that math really quickly. It's going to be $65.48. So if you were only taking that car for 2 days and going 150 miles, this first option would be better. If you were keeping that car for like a whole week, then this is going to be better. So that's why it's important to be comparing and writing expressions for these. Okie dokie. Make sure you have this sheet out. This next lesson is going to be pretty simple, especially the first part and all the stuff I have you doing on the homework. There's going to be a little part that's going to stretch you, so it's going to go quick. And then your homework today is actually going to be, once you're done with this lesson, you can go grab it from the setup. It's actually going to be a lesson 2 homework practice, which is on the back here. That's like the homework for this, and it's very fast. I know that looks like a lot of problems. Don't worry about it. And then you're going to go back and use your calculator on all of these, that's fine. And you're going to go ahead and do a little bit of practice on what lesson 1 was and a little bit more practice on these. And this is actually your skill check review. So tomorrow we're going to go over the skill check review quickly. And then you're actually going to take your skill check tomorrow. So what are you going to take tomorrow? A quiz. And it's okay because this is a pretty quick lesson. So let me get down to it. All right, I'm on page 357 with the horse. So turn to the very next lesson, 357, and it's on sequences. So first thing is we have a sequence. A sequence is just an ordered list of numbers. And there's usually a particular like reason to the sequence. It's not just random numbers. It's an order of numbers that is doing something in particular. And each individual part is called a term. Okay, so an arithmetic sequence is a special kind of sequence. That's the one we're talking about today. And it's found when you add the same number to the previous term. So let's add that to our sheet. Arithmetic sequence, I mean, I'm not sure. So an arithmetic sequence, each term is found by adding the same number to the previous term. You can pause this if you need to write this down. So for example, if I have a sequence that's like 1, 7, 13, and then you want to know what like the next ones are, you can actually describe the sequence, and you're going to be doing some of that today. If you describe the sequence, you're telling me like what the difference is between each of these. So from 1 to 7, if I do 7 minus 1, I get 6, so I'm adding 6. 1 plus 6 is 7. 7 to 13, I'm adding 6 again. So that's going to be my sequence. So I'm going to add 6 to 13, that's going to be 19, and then I add 6 again and add 6 again. And so my description of the sequence is adding 6, and like my next 3 terms is what are the next 3 numbers. So 19, 25, 31, I hope that's right because I'm adding 6 quickly. So that's it. That's pretty much most of the lesson. So let's take a peek. Down here at the bottom of this page, there's horseback riding. So the number of students who went on each horseback riding trip is shown. So these terms are going up. This is first term, second term, third term, fourth term, fifth term. So that's important. It's not like we're skipping around. And it looks like it's going up by, this is 1, this is 2, this is 3, this is 4. Do these numbers follow an arithmetic sequence? Are they going up by the same amount each time? No, this is going up by 1, 2, 3, and 4. So this is not a sequence, okay? What about this sequence up here? Let's continue it. 1, 2, 3, 3, 4, 5, 5, 6, 7. So this is going up by 2. We're adding 2 to the previous one. 8, 9, 10, 11, 12, 13. We can continue that sequence on. You can also do it with decimals. Don't be afraid. So if you can't see right away that that's going up by 0.5, you can take your calculator and subtract 1 term from the last one and figure out, oh, it's going up by 5. 0.5, excuse me, 5/10. It's going up by 5/10. This is going to be 2.5, 3, 3.5. This one is add 5/10 to the previous term. So this is the description, and these are the next 3 terms. Ta-da! Arithmetic sequences. That's really all that you have to it. So next page, let me show you some examples. This one right here. Describe the relationship. That means what is going on here. Each term is found by adding 5 to the previous term. So writing add 5 is just fine. Add 5 or plus 5 if I ask you to describe a sequence. Continue the pattern to find the next 3 terms. The very next 3, well, you start with where you left off, add 5, that's the next one. Add 5 to 28, not to 23, that's the next one. Add 5 to 33, that's the next one. So your next 3 terms are these 3. Same thing happens with the decimals here. The difference between these ones, if I subtract them or if I count up, and subtraction, the same thing, that's going to be 0.2. So I want you to pause right now, and I want you to do A and C. Pause and do A and C. All right, well, this one's pretty easy. I know this is going up by 13. Don't just assume that they're always the same, but 26 minus 13 is 13. Is 13. So if I'm describing the relationship between them and then writing the next three terms, those are the two things my question asks. So if you only describe the relationship or if you only added the terms, it's a problem. So on A, we're going up by 3, and the next, or no, by 13, and the next three terms is 39, 44, 42, 52, 3, 4, 5, 65, 79. And you have a calculator, so there's no reason that these should be incorrect by making mental math errors. This one is going up by 0.3, 0.3. So on C, it is plus 0.3. That is the description. And the next terms, 1.9 plus, let's see, 2.2, 2.5, 2.8. And if I'm going too fast and making errors, you know why, because I'm doing it mentally. Okay, there's one other thing that's most difficult here. You can actually write an expression to show, like, if you know which position it's in. So this is the position, and this is the value of the term. So this just means, okay, it's the first term, it's the second term, it's the third term, it's the fourth term. So it's always going up by 1 over here. And over here, maybe your term is going up. Oh, look, it's going up by 2. So what's really happening? What are you doing to the first number to get 2? Well, you're multiplying it by 2. 1 times 2 is 2. That's the operation. What are you doing to the second number to get 4? Times 2. What are you doing to 3 to get 6? Times 2. What are you doing to 4 to get 8? Times 2. So you can actually, like, say, oh, so it's like the position times 2. So I can just write like 2n, 2 times whatever. So then I can ask you, okay, what is the value of this to the nth term? And it's 2n. Or I can say, ooh, what is the 40th term? And instead of you writing a huge chart going all the way down to 40, instead of doing that, you would use 2n and just say 2 times 40, which is 80. You could answer right away what the 80, that term is going to be. Okay, so here's another example here in a word problem. The greeting cards that Meredith makes are sold in boxes at the gift store. And in the first week, that's week 1, they sold 5 boxes. The second week, there's 5 more boxes. So it's 10. Third week, 15. So 1 times 5 is 5. 2 times 5 is 10. 3 times 5 is 15. So any number that is, n times 5 is going to give you 5n. So this is your expression for that. So if I say, okay, what's the 100th one? Well, you just do 5 times n, which is 5 times 100, or whatever I ask you, whatever term I ask you to give, and you're able to write down what it is. All right. Okay. So let's take a look at number 4 on page 360. I'm just going to kind of show you an example. So Hannah has a doll collection. I'm kind of going to redo this chart here. 1, 2, 3, 6, 12, 18. So this is going up by plus 6, right? Each time. And this is going up by 1, so we know that these terms, this is an arithmetic sequence. So I want to know what's the operation. What am I doing? So every year, she gets 6 dolls. So my expression here is 1 times what is 6? Times 6, right? 2 times what is 12? Times 6, right? 3 times what is 18? Times 6, right? So if I add 1 on here, man, I should have left some room. If I add n here, n times what? Times 6, which is 6n. So your expression is actually 6n. Any number that's here, you have to times by 6 to get this number. So n times 6 equals 6n. So I can say, okay, when is the 25th year? Oh, 6 times 25. See, 4 of those would be 100. $150. Holy moly, that's a lot of dolls she'll have after 6 years. 25 years, excuse me. So that's kind of what those look like. We won't do as much with those. It'll be like one problem on your skill check. So you don't have any homework from this page. The homework that you have, if you don't already have it, is going to be this page. So let me scoot out and show you. Yes, you can use a scientific calculator on this review. Showing your work on these top ones is going to be taking these guys, popping them in and rewriting that expression, okay? Down here, you're going to describe the sequence. That's why there are 2 lines. You're going to tell me plus whatever, and you're going to tell me the next 3 terms, okay? On the back, there aren't any lines. There's another one of these examples, and it asks about the 7th week, so try to write an expression. To help you with that. And then you've got a couple more sequences to work on when you're done. Okay, so top priorities, get that skill check review finished and the homework done. And it's due tomorrow. Thanks, guys. See you tomorrow, I hope.